Hey everyone! So today I will be talking to you about something called a potentiometer. On Tinkercad, you can see that it has three legs, and this is what its circuit diagram symbol looks like. A potentiometer is a device that allows you to adjust voltage. But the way we're going to connect it, we actually are not going to be adjusting voltage, we will be adjusting current. So what it really is a variable resistor. It's the resistor whose value you can change. Now, before you set everything up, you kind of have to choose what is going to be the value, the max value for your rheostat or potentiometer. We call it a rheostat if we connect it as a variable resistor. So the max value right now is 250 kilo ohms. That's a little too much. So I'm just going to change it to 10K. So how will that work? Well, let me go ahead and build a circuit and show you exactly how this works. So I'm going to start with breadboard small, and I'm going to get myself a battery, and I will get my favorite 3 battery pack, which is 4.5 volts. I'm going to rotate this and connect this up over here. So right now I have power on the bottom rail, I have ground on the rail right above it. I'm going to route my power all the way to the top so that I can stretch a circuit. And this is the circuit that I want to build. So you can see that in the circuit I have a battery, I have my rheostat, and then I have a combination of a resistor and an LED. Now you should ask yourself, well, a rheostat is a variable resistor. Why do I need another resistor protecting my LED? But you have to keep in mind that the bottom value of your rheostat or your potentiometer is 0. So when the dial is cranked all the way to 0, there is nothing protecting your LED. So that resistor over here is very much necessary. Also notice how I'm connecting my potentiometer. This is why I'm saying I'm connecting it as a rheostat. One of the legs is not connected at all. So what is this leg? This leg is called a wiper. It's right here, and it's the middle one. So let's go ahead and connect this. So my terminal 1, according to my diagram, is connected straight into my battery. So I'm going to connect my terminal 1 over here. And then I'm going to connect my wiper into the resistor and the LED. So it's no longer red over on this side because the rheostat has an ability to take down the voltage as well. So I'm going to choose this one to be blue. So I'm connecting my wiper. Now I'm going to connect my resistor. I'll rotate this. And the value that I'm going to choose, I don't want to choose 1K for this demonstration because 1K is quite large. So I'm going to choose something very small, like 200 ohms, so that we can clearly see the dimming effect. And then I'm going to connect my LED to my resistor. Make sure your positive leg is connected to the side of the resistor. And then I'm going to connect the negative leg into the ground, which is black. All right, so let's test this out and see how this works. So right now you can see that my LED is very much lit, and I'm going to start adjusting my rheostat, and you can see how it's dimming and dimming and dimming and becomes super dim by the end. So you can use a rheostat to create a dimming effect. Now, here's the deal with the rheostat. What you're doing is you are decreasing the current. If I were to measure a current in my circuit, I will notice that my current gets smaller and smaller as I move my wiper. So I'm going to go ahead and connect my multimeter. I'm going to switch it to the amps mode. And remember, when you're connecting the amps, you need to connect in series. So I'm going to connect my multimeter instead of this wire. So this is my positive end. This is my negative end, which goes towards them. And let's see how our current changes as we move the wiper. So right now we've got 12 milliamps of current, which is why our LED is very brightly lit. And now I'm gonna gradually change my wiper. And you can see how my current goes to 2 milliamps and my LED is getting very dim to 1 milliamp. And once we get below 1 milliamp, it's very, very, very dim. So we have basically microcurrents here. So you can clearly see that it definitely has the dimming effect, and it definitely does it by decreasing the current. There is a way to set it up as a potentiometer to decrease the voltage, but we actually don't want that effect because we want to keep the voltage for our LEDs relatively constant. So the correct way to set it up for the dimming effect for the LEDs is to set it up as a rheostat.